running an emulator inside a workflow is something like really intensive. So yeah, also, for example, Firebase Test Lab offers you the possibility to see the video of your tests, while I don't think GitHub Action has any video. Like, okay, so hi everyone. Thank you very much for joining this online talk. Today we're going to talk about Devops-ify your life with GitHub Actions. So mandatory slide about myself. My name is Nicola Corti. I work as Android infrastructure engineer at Spotify, and this means that I develop SDK tools libraries for Android engineers. And today I'm not going to talk about specifically from Spotify, but I will share a little bit of my experience in the open source world. This is my Twitter and GitHub handle. And just to sort one things out, if you're looking for the slides, they're actually already on my Twitter. I just tweeted like 2 minutes ago with the slides. So you can find them there and follow over during the presentations. And those at the bottom are my hobbies. So I'm happy to chat about those kind of things if you want to reach out. And I'm also really passionate about open source. So I'm gonna catch the opportunity of this talk to share some of the libraries where I'm like contributing. And I want to send out the invite for you to participate. If you're looking for some open source contributions, I'm more than happy to mentor other folks that wants to join this awesome world. But yeah, let's get started. So the talk that I'm going to deliver today, it's really going to be about continuous integration and continuous delivery. And in order to set to set expectations, I want to spend some minutes talking about continuous integration and continuous delivery as a process, just to make sure that we are all aligned on the same page. So what is continuous integration? Continuous integration is basically a process. It's like a conceptual process that I invite everyone to set up when you are developing software. So it all starts from how you versionate your software. So I assume you have like some kind of versioning system, being like Git, Mercurial, or other software. And you will have your snapshot of the current status of your code base. Let's call it the main branch. So at a certain point, you or someone else want to integrate a new change. A new change can either be like a bug fix, or it can be like a new feature because you're adding a new screen to your Android app. So there is this process that is called pull request, but can be called in any other way, change request, merge request. So there is the intention of someone to introduce new code within your code base. So here is where the continuous integration process actually starts. The first thing that it's part of the continuous integration process is to build. So you want to take this new change and build it within the code base to make sure that the code base is still compiling. So building is actually the first form of testing. You want to mutate your code base from a status that is compiling to another status that is still compiling. You don't want to break your code base. So the first thing we have to do is to build our code base with these new changes. Then it's up to tests. Tests can be a variety of different things: unit test, integration test, and they're basically a mechanism to ensure the quality of your code. So you want to write tests to make sure that your code is bug-free. And then you probably have also some analyzer of the code, static analyzer, specifically tools that read through your code and try to spot potential bugs, like a variable that might be null and might crash your app in production. And this is a loop. Sometimes, most of the times, there is also a human step within this loop. So there is like the so-called code review process. So another human will check the code, will read it, and will say if the code is correct and can be integrated or not. Once all those steps are green, the code can be integrated and merged into your main branch. if one of these steps is failing, you want to run the loop again and again and again. So this loop can run multiple times. And the idea, what's the end goal of this? As I already said, the end goal is to ensure the quality of your code base. You want to make sure that the quality doesn't drop. So this is all about continuous integration. Let's move over to continuous delivery. Continuous delivery is about delivering new version of your software, so sending out to the public. Let's say that you have your main branch again, and then at a certain point in time, you pick what is called a candidate. So you say, like, at this point in time, my code is so good that I could imagine delivering it outside to the public, creating a new version. So the first thing that you have to do is creating an artifact. An artifact, in the case of Android, is nothing more than an APK or an app bundle. So you want to basically consolidate your code base in a way that others can also consume it. If it's a Java library or a Kotlin library, that will mean that you have to create like a jar. If it's a node package, you need to create the node package for it to distribute. So you need to basically transform your code base in a way that others don't have to build it, and they can just use it and integrate it into the project, or use it as a customer, like download the app and use it. Then another round of tests. Those tests could either be the one that we saw before in the continuous integration, or they can even be more refined tests that are happening only in the continuous delivery. To give you an example about this, let's say you have an Android app, and whenever you release a new version of the Android app, you want to send your APK to an external vendor, like an external team of human tester that will actually test your app to make sure that everything works correctly. This is something that you don't want to do for every integration because it will be extremely expensive and slow, but it's something that you're okay paying it and waiting for it when you want to release a new version of your app. And then deploy. So you want to make sure that your artifact reaches like a market somehow. Like if it's an Android app, maybe you have like the internal testing track. You want to send the alpha APK or the beta APK to some of your users to give them a first try on how the new app will look like. And then again and again. And this loop, again, will also run multiple times. For example, you might have one round of this loop for the alpha, then you have the alpha 1, the alpha 2, then you go to beta, and then you do, again, another loop. And then when you're done, like you say, like, hey, the quality is correct, everyone is fine with this, then you actually create a new release. You tag a new release. You say like, oh, this is version 2.0 of my app, of my library. Those two processes, they work together. They have slightly different focuses, but they are really similar in their nature. And to implement them, you could either do manually or sometimes use like an external tool, like a so-called CI/CD tool. And there are a huge variety of them out in the market. Let's mention like some of them, like Travis CI or Circle CI. They are really famous in the open source community. If you do like development on GitHub or other platform, you will find them. They're really used. There are other CI tools like Bitrise. They are more focused on mobile, like developing and releasing Android apps, or more enterprise solution like TeamCity, or even like, I think that the open source de facto CI/CD tool is Jenkins. Jenkins is an open source tool that you can download and install on your machine and will help you setting up your pipeline. And this contains a lot of plugins and integrations that you can install to customize your CI and CD loop as you want. But today, we're going to talk about Github Actions. So Github Actions is another CI/CD tool, but it's special in a way. And today we're going to see why is like a killer product, I think, from my point of view. So the first thing, why it's a killer product, because it's integrated inside GitHub. It's just there. Like it's a tab that is in the main page of your repo. You just click on Actions and you see your CI and CD loops that are running. Also, it's free for open source repositories, for public repositories. So I do a lot of open source. So this comes really handy for me. But really, if you're on GitHub, you will find it extremely convenient to set up GitHub Actions. And if you're not yet there, I really invite you to take a look, because I think the product is amazing. I mean, I'm not working for GitHub, but I have a lot of projects over there, and I really that really streamlined my process a lot. So I really suggest you take a look. And if you have private repo on GitHub, you can actually run GitHub Actions on those up to 2,000 minutes per month. This is handy, for example, if you have like some side projects that are not yet confident open sourcing, but you still want to run a CI for that. Maybe you have your Android app and you want to send it to the Play Store. You could do it privately. No one will see your code yet. Then I really invite you to open source it at a certain point. A couple of other features of GitHub Actions that are really crucial and extremely nice are the custom actions. So developers in the open source community, they can create building blocks to help you compose your GitHub action pipeline, and you can reuse them. So far, like on the marketplace, there are more than 4,000 actions, and they're growing every day. It's really easy to create a new one, and you will be amazed by how many there are there, also for Android, and you can use them as inspiration to build your own. Then another extremely cool feature is that you can run workers for every different platform. So you can have your code running on Linux, macOS, and Windows. And this is extremely handy if you're building like a command line tool or a library, or even an Android app, and you want to make sure that all of your coworkers, independently on which operating system they're using, they are able to build your app. And this is really handy because for some open source projects in the past, I was using 2 different CIs, one for Windows and another for Linux and Mac. And sometimes one of the 2 would break for, I don't know, reasons. So that was really inconvenient. While having everything in the same place is sort of handy and really a plus of this new tool. And finally, I will focus a lot of my examples afterwards on Android. Why? Because, I mean, I'm an Android engineer, but I think that this tool is really great for Android developers because the workers, they're really designed to work well with Android. For example, this is the Ubuntu latest, and it runs Ubuntu 18.04, and it has some packages already installed, but the beauty of it is that it has all the Android SDK already installed. So you have the build tools 30 and the SDK platform 30, and you don't have to deal with licenses that are not accepted. This was like the major source of pain for me for CIs. Like you try to run and then the CI fails because the, I don't know, SDK build tools 30, you haven't accepted the license. Okay, I mean, I just need to build, you know. So in this case, you already have everything on board and it works just great. So for Android apps, this is really perfect. Okay, so now to introduce the concept of GitHub Actions, I need to talk about some building blocks. The first one is workflows. So on GitHub Actions, it's all about workflows. What is a workflow? A workflow is basically a YAML file that you put inside your repo. You can have one, for example, one for building, or you can have more. You can have one for building, one for releasing, and one for doing, like, I don't know, the cleanup, whatever. So to understand the workflow, we need to introduce 2 other concepts. First one is the triggers. So triggers are events that are firing your workflows. Let's see some of them. For example, a new pull request is opened, or a commit is pushed to some branch, or a new comment is sent to an issue or a pull request. Or you can also have a scheduled trigger, like every day at noon, trigger a workflow. And to give some like more concrete examples, for example, you can say that whenever there is a pull request, you want to run the build workflow. Or whenever you push to master, you actually want to run the build workflow. Or maybe you have another branch like release, and you want to say that whenever you push to release, you want to run another workflow, the release workflow. Then you can have like this comment trigger that triggers the cleanup workflow. So whenever I comment like /close, it will close the issue or it will lock the issue and will help me automate stuff like management of my repo that I will have to do manually. And then the schedule workflow, like every midnight, just go through all my issues and close the old one, the stale one. So every workflow inside can run one or more jobs. So for example, we can start with a single setup where every workflow has just one job and is running that from the beginning to the end. Or we can have a setup where there is one job and the output of that job is used to run 2 other jobs in parallel. For example, the release workflow will have like a Gradle job that will create the release, and then we'll upload it to Bintray and to Sonatype separately. So it's up to us to decide like if those jobs internally, they can all run in parallel, or they are sequentially, or they are mixed. Like in this case, I could say first run Gradle, and those 2 depend on Gradle. So they can run in parallel, but I have to wait for this one to be executed. So now I want to give a concrete example. So let's see how our workflow will look like. And this is going to be extremely easy. This is the workflow to build your app. So we create this YAML file and we start writing it. We give it a name. So the name of this workflow will be build. Then we need to define the triggers. So when this will be run. This will be run whenever there is a push on any branch, or whenever there is a pull request on any branch. So if you open any pull request against my repo, this will be executed. So these are trigger parts. Now let's go back to the jobs. Jobs. We define one first job and we call it Gradle. I usually call them Gradle because they do Gradle work inside, but you can call it build test, however you want. We define where it should run. This should run on Ubuntu latest. And then steps. So here we define the steps that this Github Action workflow will have. There are actually 2 steps. The first one is checking out the repo. So you want to check out the code, and you just need to have the code inside the runner to do whatsoever. And this is generally the first step that every job will have. And then you want to build everything, and you call Gradle assemble. So let's take a closer look at those 2. So there is this name that is like description, but the important part is this key that is either uses or run. So let's start from this one, run. This is easier because it's just a bash command. So what I'm doing, I'm calling the Gradle Wrapper and I'm calling assemble. And this will basically assemble my app, all the flavors, and we'll create APKs for everything. That's fine, pretty easy. This one is a little bit more complicated, but not much. So this key is uses. Uses means that it should use another Github action. So I'm not saying the bash command to execute here, but I'm saying like use someone else. In this case, I'm using actions/checkout. So if you go on github.com/actions/checkout, you will find a repository there that contains these Github actions. So this is like the user actions, and this is the checkout, the name of the repo. Actions is not actually a user, is an organization. So there you will find a lot of actions. And in this case, I'm also specifying the version, like @v2. So I'm saying like, I want version 2 of this. This is something that I really encourage you to do because it will make sure that you still use version 2. If you don't add this, it will always use the latest master, and that could break. And then one last thing, actions. Like the fact that that we're using actions/something else, it means that we are using a first-party action. So this is basically from GitHub. And on this case, we are sure that this will work correctly because they pay a lot of attention on this. This is like maintained, bugs are fixed, it will be fine. Okay, so now I want to move over to some real-world examples, like open source library. You can go there, like on this repo, and see what they're actually doing, and investigate the action workflow and use them maybe as an inspiration. So the first one I will present is this one, Up Intro. So Up Intro is a library to help you build like the introduction for your Android app, like the carousel with slides that you see when you install the app the first time. And historically, we used to use Travis. Then we migrated to GitHub Actions. And let's see how our GitHub Action workflow looks like. It's pretty trivial. Like, it's not that complicated. It just it's really similar to the workflow we saw before. So we have a checkout, we run KDLint, we run detect, and we run all the other tests afterwards. And again, there is just one job that is called Gradle. So what's the problem here? I mean, we actually, this was the original way. Now we improve the performance of this. And we thought, like, you know what, KDLint, detect, and all the other tests, that can actually run in parallel. Because this KDLint maybe will take 1 minute, detect will take another minute, and run all the tests will take 2 minutes. And so the total will be 4 minutes. And it's like, yeah, okay, we can do better. So what you can actually do is have 3 separate jobs, like one that will run KDLint, one that will run detect, and one that will run tests. And this is also convenient in the way that now they can run in parallel. And if previously you had a failure with KDLint, the build will just fail and will not run detect and the test. So maybe you fix KDLint, and then, oh, now also detect is broken. Annoying. Then you fix detect, and now the tests are broken. Yeah, even. So it's really annoying for our contributors. While this setup instead will show on the run, will show all the separate job and their status. So basically, we run the test even if KDLint is broken. Like, they're completely independent. This is really a plus. Like, if you do open source, think about the time to first feedback. Like, how much slow your CI is. Like, if your CI takes half an hour, your contributor will be super annoyed, and they will just say, like, oh, come on, it's like half an hour, and then I got, like, I don't know, on empty, I missed like a new line at the bottom of the file. So this is just super annoying. So let's try to pay attention to your contributors and make sure that everything works smoothly and as fast as possible. Also here, you see on the right, we have these 3, KDLint, detect, and test, but we have also another one, build debug APK. And so this build debug APK actually is another job and will allow you to have debug APK. So developers can actually download the sample app. So there is a sample app inside the repo that tries this library. And I mean, previously you would have to check out the repo and run the sample app on an emulator. It's annoying. Well, here we can offer this already. So let's see how the code for this job will look like. This is pretty trivial again. So you build the debug APK, you first check out the repo, then you build the debug APK with assemble debug, like you call the assemble debug Gradle task, and then you call this other action. This is again from Actions, so this is from GitHub. It's called upload artifact, and it wants 2 parameters, the name and the path. So in this case, we are calling it upintro simple app.apk, and we are telling him where to find it. Example bit outputs apk debug example debug apk. So GitHub Action will just check if the file is there and will upload it and add it to the report of the job. Okay, so now let's move over to something a little bit more complicated, but still really interesting to see. So detect. I don't know if you know detect, but if you do Kotlin development, you probably know it. So detect is a static analyzer for Kotlin. It's pretty famous. And historically, it used to use 2 CI systems, both Travis and Appwire. And now we migrated over to GitHub Actions. And this is just way smoother and easier to maintain for us. So let's see how the workflow will look like. So we have a job, it's called Gradle. And here we see that there is a if. So the if is a key that can be used to define a condition that will skip the workflow. So in this case, we say that if it doesn't so here it sounds like a bit complicated, but it's not. Like if not contains GitHub event head commit message, CI skip. So if the commit message doesn't contain CI skip, then you can run this job. What's the rationale behind this? The rationale is that you can commit and add CI skip to your commit message to say like, hey, don't run the CI. For example, if you're changing the README, or if you're changing the documentation, like super small change, you don't want the CI to run because the CI maybe will take 20 minutes and you need to like, it's worthless. It's pointless even, like you don't really want to run the CI in that case. So you can do that. And then here we have like a really another interesting feature of GitHub Actions. There are like build matrices. So with strategy and metrics, we define which is our build matrix. In this case, we want to run our library on Ubuntu, macOS, and Windows. And we want to try it on Java version 8, 11, and 14. So this matrix means that we will basically have all the possible combination of those two keys. So in total, there will be 9. So I will have like Ubuntu latest with 8, with 11, with 14, macOS with 8, 11, 14, and so on. And so how do I use this? I can use it like, I can use it like here, runs on. Instead of specifying Ubuntu latest, I can use the value metrics.os. So basically 9 jobs will be created. And for every job, metrics.os and metrics.jdk will have the value that is defined in this matrix. And so the other, so we saw metrics.os, metrics.jdk, for example, I can have an environment variable. I have an environment variable called JDK version because I need to use it inside my build. And I assign it the value that I have from the matrix. So we'll have matrix.jdk for that environment variable. And how the job will look like, that's pretty similar to the others. So again, I have a checkout repo that in this case, GitHub Actions offers me like a special action called setup Java. So I can call this actions/setup Java v1. I can specify the Java version. And in this case, this will be matrix.jdk. So I will have Java set it up in my worker at the correct version that I want, 8, 11, or 14. This is really convenient because then when developers open a pull request on our repo, they will see this. They would see like the premier checks, job Gradle run like 9 times, and Ubuntu latest 8, Ubuntu latest 11, and blah, blah, blah. So you will have all the various configuration of my build matrices. And it's really easy to say like, hey, you know what? The macOS build failed because those 3 are red, or it's not working on Java 14 because these, and these are red. So it's really helpful to test all the possible combinations. So now I want to give another example. And we saw a lot of examples related to continuous integration, while I want to shift a little bit on the continuous delivery. So how we can actually use GitHub Actions to deliver some of our product. In this case, how we can release an app to the Play Store. So again, we're going to create a new workflow. We're going to set the name to release to Play Store. And we're going to say that this will run on push to branches, and on the branches called release. And then we're going to, again, have a job called Gradle. And then inside, we're going to say what we do. The first one is actions checkout. So we're going to do the checkout. Then we're going to build a Gradle. In this case, we want to create an app bundle. So we're going to call Gradle bundle release. We're going to create a release APK, a release app bundle. And then there are 2 steps that we need to do before we can actually hit the Play Store. The first one is signing. So our app bundle needs to be signed. So we use, in this case, this external GitHub Actions called sign and release. And as you see now, this is not from Actions, it's from another user. And it has some parameters like release directory, or where is the key store password and the key password. And as you can see, you can use this other feature called secrets. So secrets is a feature of GitHub Action that allows you to share like secrets, like password, keys, GPG keys, whatsoever, and they will be available inside the build. So the worker can have access to those and can use them to sign your APK. And again, if you go on roadkill/sign Android release on GitHub, you will find the repo, and you can actually see what the GitHub action is doing over there. And then the next step is like, once you have everything signed, you actually need to upload it to the Play Store. And so to upload it to the Play Store, again, we use another action, and then we need to specify things like the package name or on which track, like you want to upload it to beta, internal track, alpha, or to production. And where is the release file? And this is really easy. It's like 40 lines of code to release to the Play Store. Like, you will be amazed of how short your workflows has to be, because it's really compact and it allows you really powerful things. So I really invite you to take a look. Now, so I've added this part because I noticed that there is a lot of confusion in the open source community related to caching. So how caching works on GitHub Actions. So I added this section recently, and I think it's worth, because caching is something that you can use to speed up your builds. And when you're working with Gradle, you have to download a lot of stuff. Like if you do Android, you probably have tons of dependencies, and your dependencies have other dependencies. So they all need to be downloaded. And you don't want to re-download them every time. You want to cache them. So to give you an example of how caching works on GitHub Actions, I will use this other open source library. It's called Chucker. Is on Chucker team/Chucker, and it's basically on the debug tool for Android, and is on a HTTP analyzer. So you can basically see the traffic of your HTTP instance on Android. So you have like a list view, like a recycle view with all the entries. And it's really handy because it's helpful for debugging to see what's going on. So here we use caching because we are really like keen to have a fast CI. So caching will look like this. Again, we have a job. This is a job for detect, but the interesting part is this one. So we have a step called cache Gradle folders. It uses actions cache v2. So again, we are using the one from GitHub. And then we need to provide some parameters. And this is the critical part. So first we need to say which path we are interested in caching. For Gradle, we're interested in these two. Like in the home of the worker, Gradle caches and .Gradle Wrapper. So we want to cache these two folders. And then we need to specify a key. So how we identify this blob of file that we're caching. In this case, here we use cache-Gradle-hash-file build.Gradle. So these will compute the hash of build.Gradle, and we will have like a hash over there. And then here we need to define also these restore keys. Okay, so this is maybe not obvious what is actually happening over here. So to fully understand this, I will actually complicate the workflow a little bit, and I have some real world examples. So let's take this other job. So this is the test job, and as a strategy. So in this case, we are testing Kotlin, 2 versions of Kotlin. So we're testing the latest released version is 1.3.72, and we are also running 1.4.m3. So on the 3rd milestone on Kotlin 1.4, because we want to make sure that our library works fine on the latest version of Kotlin, but also on the upcoming version. So we will have 2 jobs, and we set an environment variable. And yeah, here's the caching. So let's zoom in and let's see how this is working. So again, cache Gradle folders uses actions cache v2. We want to cache these 2 folders. Now the cache key is a little bit more complicated. it's like cache-gradle-matrix.Kotlin version. So it will be one of these two values. And then we're going to do the hash of build.gradle. Okay. Then inside the restore keys, we provide two restore keys. The first one that is cache-gradle matrix version, and the second one that is just cache-gradle. So let's try to actually run. Like, let's see how a run of this workflow will populate this key. It will look something like this. Will be cache-gradle-1372-dd. This is the hash of this file, build.gradle. And now maybe you're also wondering, why is he hashing build.gradle? Like, what's the point behind that? I mean, we will see. So let's assume that now inside the cache of GitHub Action, you have these 4 entries. So it means that in the past, there were run of GitHub Actions, and those run, they succeeded, and those 2 folders, they were stored in the GitHub Actions cache, and those are like the keys that were stored. So we run once for 1372 and once for 14M3. And we have 2 different hashes, DDEA and FEB. So it means that basically between those 2 runs, the build.gradle file changed. Like I don't know, changed something, added a new dependency, I don't know, something changed over there. So they are different. What happens? Now we run our job. The first thing that we will do the repo. We will check out the repo. And then there will be this step. So this step will compute this key, that in this case is cache-gradle-1372 with the hash. We'll go inside the cache and we'll say like, hey, I'm about to run this. Do you, by any chance, do you already have it? And GitHub Action would say like, yes, I already have it, because this same job with the same build.gradle with the same Kotlin version was run, I don't know, 1 hour ago. So I already stored those 2 folders. You don't need to re-download all the Gradle dependencies. I already have it. So just restore that folder, and you don't need to go like on JCenter or Muffin Central to download everything. It's just there, and that will save you a lot of time. Like, can save you 1 minute. That is a lot, or even more. It depends on how many dependencies you have. But yeah, this is really convenient. So we have this job, and this will just rerun and will be really fast. So what happens actually if I change the build.gradle file because I maybe add a new dependency? So I added a new library. So the hash will change. The hash now is 017. And so when I run my job, again, I do the checkout, the key is computed, Kotlin version is the same, 1372, and then the hash is different. And so the GitHub Action doesn't have this stored. So it will use the restore keys. So now the restore keys are like a list of basically pattern that will be used to match the keys that are stored, the caches that are stored inside GitHub Actions. In this case, we have cache-gradle matrix version. This should be Kotlin version, sorry. That will be 1372 or 14M3, or we have just cache-gradle. So in this case, GitHub Actions will say like, hey, I don't have this exact match, but I have something that is a partial match from your restore keys. So you have these 2, 1372 run. They are with different hashes, DD or FE. Which one would you pick? So of these 2, GitHub Action will pick the most recent. So the most recent, I don't know, will be one of these 2 will be restored, and then at the end of the job, a new entry will be added for this one. If you also run on a new version of Kotlin, because you have a new job and you run it on 140, that is not here and is also not here, then GitHub Action will use the last restore key. So we'll just say like, hey, you know, I have cache-gradle, stored. Which one should I use? They all match the latest. So the latest stored cache will be restored, and then a new cache entry will be added at the end. This is how caching works on GitHub Action. I hope I clarified a bit. And if your job is slow, consider using it, because this will really speed up your workflow a lot. So that being said, now I want to take like some minutes, if I still have time. Guys, I think I have, but feel free to stop me if I'm going too long, because I have a repository, a sample repository, and I want to set up a GitHub action with you, like step by step, like live coding sort of. So this is the repo. It's on GDG Pisa. That is one of my GDG that, by the way, I catch the opportunity to send greetings live. And this is the repo. It's called GitHub-Actions-sample. So you can actually go there and see what I do step by step. So this is really trivial. It's just like an empty Android app. I used one template to generate it. It's this Kotlin Android template. And it's an hello world app. It's really, it's doing nothing, but we're going to use this to set up GitHub Actions. In the template, by the way, GitHub Actions is already set up. So for the sake of this example, I just removed it, and I will set it up now with you. So again, it's trivial. There is an app folder inside that contains the app project, and you can run check to run all the checks. It's a simple setup, but like really, there is nothing really weird. And how we set up a new action? Well, as I said before, there is a tab called Actions. So we just click here and we see where we go. So here we arrive to the landing page, and GitHub welcomes us with get started with GitHub Action. And it also tries to identify language. It says like, oh, this is like the workflow made for your Kotlin repository suggested. But this is like sort of really stupid. So this is like, they offer us a workflow to do echo hello world. It's not exactly what we need. So probably we need to customize it. But if you would have like, I don't know, Terraform configuration, or even like if GitHub Action recognizes that you have Rust or Ruby or I don't know, Go project, it will actually offer you a more specified sample. The Kotlin one, unfortunately, is not there yet. I really hope they will add it soon. And in this landing page, by the way, there is also this this thing at the bottom that I really invite you to take a look. Those are like management, repository management workflows. And they contain like sample actions that are not necessarily related to the building of your app. But for example, like you can send greetings, like you can send a message whenever some people like open a pull request, or you can label automatically things based on the folder. Like this is related to core, this is related to UI, if it touches XML, whatever. And then stale action is actually really helpful to close issue and pull requests that are old. So those are like, again, starting point that you can use to get inspiration. But in our case, we start from the first. So we get a simple workflow and we say, set up this workflow. We click here. So we're going to set up a build workflow. So we create a new file inside GitHub, .github workflows, and we call it build. And then here we're going to do it step by step. So we give it a name, we call it build. It's really commented out a lot, so this will help you if you need support on, like, you know, filling in your workflow. And then we go to the job section. So the trigger is just on push to branch master and on pull request to branch master. That's fine. But let's see what we actually do inside the job. So the job is called build. We'll run on Linux, and we'll have some steps. The first one is the checkout. And then there are two steps, like echo hello world and echo multi-line. Okay, so we don't really need this. So the first one is like checking out the repo. That's fine. And the second one is running a one-line script. So we don't really want to do this. We want to, like, you know, like run all the checks. And what we do here, we call the Gradle Wrapper. So Gradle. So one little note, this environment is sort of like, has some sort of auto-completion. So you see, like, it suggests you things. So if I write name, like, it will tell you, like, hey, this is the name to display on GitHub. So you can do, like, check out the repo. And then I can, actually create a new pull request. So set up the build. Create a new pull request. Yeah, I don't have much time to write much here, but like just setting up the build workflow. Okay, and click create. So now GitHub Actions sort of starts, and GitHub realizes, like, hey, this PR contains a workflow. So let's actually start running it. And you see that it appeared here. So I'm running build on pull request. And if you click on details, you will actually see that it's running. Like now it's doing the run all the checks step. So while this runs, let's go back and let's add another action. So another action here. So we reuse the sample one. I want to use, I want to give you an example of the action that use the comment. So I'm going to create the rebase. And I will actually use one that is already written by someone else, this one. So on this side, you have like the marketplace, so you can access all the other actions that are written by others. Or you can go to documentation and have some like help on how to set up things. So this one is the one that I'm interested in, automatic rebase. I really invite you to take a look at the marketplace listing, because sometimes there are useful things. For example, here there is a GIF that explains how things should work. And yeah, there is also a sample. So I will actually just steal it and copy it completely, and I will put it, oops, here. Just to walk you through quickly, this will run on issue command. Issue command is a misleading name, but it's basically running every time that a comment is added, either to a pull request or to an issue. So it's not only for issues, but also for pull requests. It's called automatic rebase. And we'll check out the code and we'll run this rebase 131. There is an external action. So let's create a new pull request. Rebase. Rebase workflow. So in this case, GitHub will not show anything here because I'm not adding anything that has a trigger on pull request. This has a trigger on issue comment. So we'll just not run, and I can just merge it. Okay. So this is still running. In the meanwhile, I want to show the last one. So the last workflow that I want to show is a little bit more focused on continuous deployment, continuous delivery. So this will be the release workflow, and will basically offer the APK. So how about the trigger? We want to run it when something push to, ideally here I would love to write release, but it's a bit annoying to create a new branch on the GitHub UI. So I will just say that whenever it goes to master, it will actually run. But I want to disable pull request. So whenever a new commit is pushed to master, this workflow will run. Again, there is a job called build, will run on Linux. We'll have some steps. The first one is to check out, then we need to build the APK. So in the README, I added some information. So if you call assemble release, the APK will be available here. So let's do it. So if I do the build the release APK, and here I do like Gradle assemble release, then here I can use the upload artifact action. So if I go here and I select upload artifact, it's this one. By the way, you see that this is by actions and as this verified badge here, because this is basically by GitHub. And so we are safe that we can use it. So we can just copy. So we just copy the code here and we go here. This is not well indented. Okay. So this will run upload the release APK. We call actions upload artifact 210. The name will be release APK, and the path is the one that I have here. Okay. So now I can create a new pull request. And then I think I'm running short on time. So okay. So let's go back to my two pull requests. Set up the build, finished. It's green now, I think. Yeah. This was green. It took 3 minutes, so I can just merge it. So this was the first one. So now let's go back to my release workflow, this one. So now since I merged the other, I can actually show you what happens if I write rebase here. So let's try it. So what is happening under the hood is that now a GitHub action for the issue comment trigger will be started. And this /rebase will fire. And then this takes some, generally 1 minute. But you will see that then at a certain point, GitHub action here will appear and will say, hey, I rebased your branch from this commit to this other commit. The reason is because, yeah, here we go. GitHub actions bot force push the release branch from this commit to this other commit. So they did the release, the rebase. Yeah, and it just works. So now I can just merge it. And if I go inside actions, and I see that I have three workflows, sorry. One is the build, and this is the one that was running before. Then I have the rebase, this is the rebase action, and then I have the release. So this one is the one that will produce the APK. So now it's running. I can actually go here and see what is doing is building the release APK, and then we'll upload it afterwards. So I think I'm super short. I have 1 minute left probably. But I have already example that was doing exactly the same thing. It's a private repo, but yeah, in the actions I have this one called prepare APK, and it at the end, like this took 5 minutes, but at the end there will be like an artifact here called Release Apk, and you can just download it or delete it. And it's really convenient because people can just like get your APK from there. Yeah, so now this guy will keep on running, and I will be back here because I think I'm off with the time.
Thanks, Nicola.
Yeah,
awesome session, and it was very informative. So we have a lot of questions. We don't have time for all the questions, but I will pass on a few questions. So first one is that can we use instrumentation test with GitHub Actions?
Yeah, okay. So there are some custom actions that are running an emulator on the, I think the Mac or the Linux instance. I haven't really played with them. It's on my to-do list. So it seems doable. So you will have to look into that. But if you have like a lot of tests, I really recommend you go like on a cloud service like Firebase Test Lab or Genymotion Cloud, and you use them because yeah, you're like still sort of, I don't want to say abusing of the workflow, but you know, running an emulator inside a workflow, it's something like really intensive. So yeah, also, for example, Firebase Test Lab offers you the possibility to see the video of your tests, while I don't think GitHub Action has any video. Like you can't really see what the emulator is doing. So I remember in the past I had scenarios where like, oh, the tests are failing because there is, I don't know, a Google Play service notification that is sticky, and my tests are clicking the notification instead of actually clicking the burger button. So yeah, those are like really painful to debug.
Yeah.
So yeah, I think if you have a small library and you have some espresso test or like a sample app, you can start with that. But then I really suggest you move to, like, if you have a big app, you definitely need to move to something more like enterprise.
Yeah, makes sense. So rest of the questions you can ask to Nicola directly in Twitter. He's active in Twitter, and yeah, thanks for taking time and joining here. We really appreciate that, and